The information board shown below was seen by a river in the Italian mountains. Okay, so then we've got, what's it say here? It gives a monthly data about the volume of water flowing past a cross-section of river every second. Write down the months with the greatest mean flow of water. Well, there's a lot of information here, but we can see box and whisker plots, can't we? The mean flow is the dotted line, if you notice, the broken line there. So it's the key there, is in the data, isn't it? Okay, so the mean flow will be that broken line there. So the one with the greatest, well, we just look at where it peaks, and it peaks there, doesn't it, in that month. Okay, so in that month, and that month is May. So they want the months, we write down May, and the greatest mean flow, well, we just need then to take a reading from there, yeah? And it does say estimate the greatest mean flow, because the scale here isn't particularly great, isn't it? Okay, you know, there's no, it's not graph paper, okay, but the greatest will be at the peak there, so it will be somewhere there, won't it? Now, of course, if we've got 15 in the middle, between 10 and 20, I'd say that's probably about 17, if you think about it. 15 is there, yeah, that's about 17, so that would be my greatest mean flow in the month of May. Okay. And we can put meters cubed per second. I suppose we can copy those units there. All right. So then, which month had the smallest range of water flow? Estimate this range. You must show all your work in. Okay, so which month is the smallest range? Now the range, then, we look at the box and whisker plots. And remember, the range is talking about the highest take away the lowest. Okay, so obviously that had one of the greatest ones there. So we just got to look for the smallest possible box and whisker plot. And I think is it that one there? Okay, the box there is small, but actually the gap there is really small, isn't it? Okay, so I'd say that's going to be February. Okay, okay, and the smallest range, and we've got to estimate this range. Okay, so we've got to see what it is. Okay, well, so we just take those measurements there, yeah. So I'd say, look, the least, well, we're not quite sure. We can't see from the scale. So if we go midway there. Midway is 5, isn't it? So clearly then, the lowest value, okay, the minimum value for the flow of water is going to be that value there. So I'd say that's about 3, yeah? Because 4 is probably there. So we say that's 3. So the minimum is 3. And then the greatest will be there. So what should we say that is? I don't think that's quite 9. It's going to be more like 8, I'd say. Yeah. The greatest is 8, okay, or the max is equal to 8, okay. So then the range will be max take away min, which will equal to 5, okay. All right, and then it said which month had the greatest interquartile range of water flow? Estimate this interquartile range. Okay, so interquartile range is looking at the boxes. That would be the upper quartile, lower quartile. And you just got to look for the biggest box, and indeed I go for that one there, okay, because that's got the biggest box. So that's going to have the greatest interquartile range. So that month's going to be May. Okay. And then we know the upper quartile and the lower quartile. Okay, so the upper quartile will be that value there, which is 20. Okay, so that's quite nice. That's easy for us. And the lower quartile will be that value there. Okay, so again, get my ruler just to have a rough idea what this is going to look like. Okay, this is only an estimate. It's a bit higher than that, is it? Let's have a look. Yeah, it's about there, isn't it? So I'd say if that's 15, I'd say that's about 12. I'd say that's 12. So the lower quartile then is going to be 12. So then interquartile range, IQRs, upper quartile take away lower quartile, which is 20 take away 12, which is going to be 8. Okay.